Have you ever gazed at the night sky and pondered, where did it all come from? The universe, a grand cosmic ballet, has always been a source of fascination and wonder. Its vastness, its mystery, its enigma has puzzled thinkers, philosophers and scientists for centuries. Imagine the universe as an endless tapestry, woven with countless stars, galaxies and nebulae. Each thread represents a story, a journey, a mystery waiting to be unraveled. Among these countless narratives, one theory has emerged as the leading explanation for our cosmic origins, the Big Bang theory. This theory suggests that our universe began from a singularity, a point of infinite density and heat, around 13.8 billion years ago. It was not just a theory about the beginning, but about the evolution of the universe, about how it grew from that singularity to the cosmic expanse we know today. So, what exactly is this Big Bang theory that seeks to unravel the mysteries of the cosmos? Our journey begins in the early 20th century with a man named Georges Lemaitre. This Belgian physicist and Roman Catholic priest was a pioneer in exploring the vast cosmos, his mind teeming with ideas as boundless as the universe itself. Lemaitre wasn't just a man of faith, but also a man of science. He studied physics and mathematics, and his passion for these subjects led him to the University of Cambridge, then to Harvard and finally to the Massachusetts Institute of Technology. It was a journey of academic pursuit that would eventually reshape our understanding of the universe. In the year 1927, Lemaitre proposed a revolutionary idea. The universe, he suggested, was expanding. This wasn't just a casual thought, but a theory built on careful observation and mathematical calculation. He noticed that galaxies seemed to be moving away from each other, like dots on an inflating balloon. And if the universe was getting bigger, he reasoned, then it must have been smaller in the past. This idea was a stark contrast to the widely accepted model of a static, unchanging universe. But Lemaitre was undeterred. He followed this line of thinking to a radical conclusion. If you trace the expansion back in time, everything in the universe originated from an incredibly dense and hot state. He called this the primeval atom, but today we know it as the Big Bang. Lemaitre's idea was met with skepticism. After all, it suggested a beginning to the universe, a concept that seemed more theological than scientific. Yet he stood by his theory, a testament to his conviction and courage. His theory, as we now know, didn't just fade into the annals of forgotten ideas. It sparked a revolution in cosmology, laying the groundwork for our current understanding of the universe's origins. It took some time and a fair bit of evidence, but the scientific community eventually came to embrace Lemaitre's expanding universe. But how did Lemaitre's radical idea evolve into the Big Bang theory we know today? That's a story of scientific discovery, debate, and ultimately a quest for understanding the mysteries of our universe. As the decades passed, the Big Bang theory didn't just stay an idea, it matured, it evolved. Indeed, over the years this theory has been continually refined and supported through observational evidence and mathematical models. One of the most compelling pieces of evidence for the Big Bang theory is the observable redshift of galaxies. This redshift is the spectral shift towards longer or redder wavelengths and is interpreted as a sign of the universe's expansion. It's as if the galaxies are moving away from us, a motion that can be traced back to a single point of origin, the Big Bang. The theory was also bolstered by the detection of the cosmic microwave background radiation, or CMBR. This faint radiation permeates the universe and is thought to be the afterglow of the Big Bang, a powerful testament to the event's occurrence. The discovery of the CMBR in the mid-20th century was a watershed moment, offering tangible proof of a universe born from a hot, dense state. Over the decades, the Big Bang theory has been sharpened by the blade of scientific scrutiny, growing stronger with each test it withstands. The theory has been modified, refined and expanded to accommodate new discoveries and observations. For instance, the introduction of dark matter and dark energy, mysterious substances that seem to make up most of the universe, have further enriched our understanding of the cosmos's birth and evolution. The Big Bang theory is not static. It's a living, breathing entity in the realm of cosmology, changing and evolving as we gather more knowledge about the universe. It's a testament to humanity's relentless curiosity and our unyielding desire to uncover the secrets of our origins. Yet, as with any scientific theory, questions remain. The Big Bang Theory offers a compelling explanation for the birth of the universe, but it is not without its limitations and mysteries. Some aspects of the theory are still being refined, and new observations could yet reshape our understanding. But has the Big Bang Theory been proven beyond a shadow of a doubt? That's a question we'll delve into in our next scene. Like any scientific theory, the Big Bang Theory has its share of controversies and contradictions. Let's delve into some of these. One of the most significant criticisms comes from the proponents of the steady-state theory. This theory suggests that the universe is infinite without a definite beginning or end. It proposes that matter is continuously created to maintain a constant density as the universe expands. This idea contrasts sharply with the Big Bang Theory, which posits a definite starting point for the universe. Another alternative is the cyclic model. This theory argues for an eternal universe that undergoes infinite cycles of expansion and contraction. According to this model, the Big Bang was not a unique event, but merely a transition point in an endlessly repeating cycle of cosmic evolution. Some critics also point out the problems with the Big Bang Theory's explanation of the universe's uniformity. They question how different regions of the universe, which are too far apart to have ever been in contact, could have almost the same temperature. This is known as the horizon problem. Additionally, there's the flatness problem. The Big Bang Theory predicts that the universe's density should be just enough to halt its expansion and make it flat. But why should the density be so precisely balanced? This seems to require a fine-tuning that is difficult to explain. Finally, there's the problem of dark matter and dark energy. These mysterious entities make up about 95% of the universe, according to current estimates, but they remain undetected and unexplained, posing a significant challenge to the Big Bang Theory. Despite these controversies and contradictions, however, the Big Bang Theory remains the most widely accepted explanation for the origin of the universe. It has stood the test of time and faced countless scientific examinations, emerging stronger each time. But here's a question that might have crossed your mind. Was the Big Bang really an explosion? Contrary to popular belief, the Big Bang wasn't an explosion in the traditional sense. Now, this might sound counterintuitive, especially considering the term Big Bang itself seems to suggest a massive, fiery explosion. But the reality is a bit more nuanced. The Big Bang was actually an expansion, an unfurling of space and time itself, not an explosion within a pre-existing space. Imagine, if you will, the surface of a balloon being blown up. As the balloon expands, every point on its surface moves away from every other point. There's no central point of explosion, but rather a simultaneous expansion everywhere. In the same way, the Big Bang happened everywhere at once. This cosmic expansion started from a state of almost unimaginable density and heat, known as a singularity. It was from this singularity, this point of infinite density, that all the matter and energy in the universe, everything we know and see today, originated. And so, from a singularity of infinite density, our vast and beautiful universe emerged. The Big Bang Theory is more than just a theory. It's a journey of discovery. A voyage into the annals of time, the theory guides us to the very cradle of existence. It's a story that begins roughly 14 billion years ago in a state of singularity, evolving into the vast cosmos we call home. The Big Bang Theory, though faced with debates and contradictions, remains a cornerstone of modern cosmology. Its conception, evolution, and the notion of it as a colossal explosion have all been pivotal in redefining our perception of the universe. It's through this theory that we've been able to comprehend the universe's expansion, the existence of cosmic background radiation, and the abundance of light elements. The Big Bang Theory isn't an end in itself, but a launching pad for future explorations. It prompts us to question, to investigate, and to constantly seek the truth. And as we gaze at the night sky, we can't help but wonder, what other mysteries does the universe hold for us to discover?